Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. First, I have to apologize for not being around for quite a while. I have some updates. I recently joined Meta as a software engineer and I was pretty busy learning the context within our team and the company as a whole. So I have very little time to do codings. But now I'm more familiar with the tech stacks within our team, so I'm back. I will continue to update my videos and solve Leetcode problems with you. So today's problem is minimum recolors to get k consecutive black blocks. We were given a 0 index string blocks of length n, where blocks I is either W or B, representing the color of that block. So WB represents white and black. And you are also given an integer k, which is the desired number of consecutive black blocks. In one operation, you can recolor a white block such that it becomes a black block. So this is a flipping option, okay? Flipping operation. Return the minimum number of operations needed such that there is at least one occurrence of k consecutive black blocks. So this is pretty intuitive to use a sliding window because it involves k consecutive something, all right? And it involves some flipping operations. And we're going to return the minimum number of operations, so we just have to compare the current number of the operations with the minimum number of operations within each valid window, okay? So let's take a look at example here. We were given this string and k is 7, and I can see 5 blacks and 5 whites. Okay, so the output should be 3. Why is that? If we see a window like this is 1, 2, 3, 4, 5, 6, 7 characters, which is the size of the k. Okay, so here we have 3 whites to be flipped to black. Okay, so here we have a number of 3 operations, 3 recolors. Okay, and if we move further a bit, we still see 3 W's, so the number is still 3. And here we are still seeing 3 W's, it's still 3. And here we are seeing 4 W's. So we need 4 operations in this window to make this window valid. Okay, so after comparing all of those results, the minimum number of operations to make it valid is 3. Okay, so that's how it works with a regular one. But I think of a corner case immediately where there's no valid window. Okay, let's see. For here, we have k equals to 2. Okay, so we have this one that needs 1 operation. Okay, and this one needs 1 operation. This one needs 1 operation, but this one needs 0 operation. Okay, so the minimum number should be 0. Okay, so now we know we would like to use a sliding window. Okay, so but how should we really do it? Let me put it over here. Let's see the first one. Okay, and k equals to 7. First, we will need a left and right pointer. Okay, I'll put right pointer on the top because I want to move it over here. Okay, and oh, there we go. And in each window, we will have to calculate how many flips are we gonna do. Okay, so current number of, how to say that, recolors equals to 0. And we will have the minimum number of recolors, which will be set to a large number, but I think for now we will just set it to the length of the string, okay? All right, yeah, so that's pretty much set. And we will have a sliding window starting from the right, okay? So while right is valid, if it is W, we will flip it, okay? So we increment the current number of colors, okay? So I'll just put it over here. And then our R goes to the second character, which is black, but it's okay, so we can continue. And black, continue. W, increment. W, increment. Black, okay. Black, okay. Now, here, 1, 2, 3, 4, 5, 6, 7. We have a valid window here. So we need to calculate, we need to compare the current number with the minimum number, okay? So the minimum number now is 3, okay? So if we move further, it will be too large to be an invalid, to make it an invalid window, okay? So at this time, we should shrink from left. Okay, so every time R goes beyond K, we will shrink from left and make some subtractions accordingly. Like if L corresponds to W, we'll subtract it from the left and increment L. Okay, so let's write it in code to see clearly. First, we have to set up the sliding window. And we will have a current number of recolors. And yeah, I think I can just use it from here. Okay, so now the right part of the sliding window. And increment that. So the first thing is to put every valid character into our current number, okay, to increment that. So if blocks dot character at right equals to white, okay, so current number of recolors will increment, and if right is larger than or equal to K, why do we have to set it equal to K? Because here, well, R is here, so not like that. Oh, so this is index 7. Okay, 0, 1, 2, 3, 4, 5, 6, 7. When R is here, it's already invalid. So we can't go any further from here. Okay, so we have to stop it from K. Okay, so every time R goes beyond this point, we will check the left. So if blocks dot character at left equals to W, we should subtract it from the current number, okay? And then we will increment left. Yeah. And like I said, every time when it maintains a valid window of size K, we will compare it with the minimum number, okay? So if right minus left plus 1 equals to K, so that's when it's valid, we will update the minimum number of recolors to the minimum of it and the current number of recolors. Okay, and our final result will return the minimum number. Okay, yeah, I think that should work. Yeah, looks like passed all the test cases. And let's analyze the complexities. Okay, so since it's a sliding window, will be n, and space complexity will be a 1. Okay, let's submit it. Perfect, got accepted. Thank you so much for watching. I will see you in our next video.